Hello, in this video, we're going to learn how to graph some of the trigonometric functions in certain domains. The objectives are simple. We begin by identifying some key features of our functions. In this video, we're going to limit ourselves to the sine, cosine, and tangent functions. Using these key features, plotting and graphing our functions are going to be a lot easier. Trigonometric functions are also called circular functions. To explain this, we have to go back to triangles. We have defined, for instance, the sine function to be the ratio of the length of the opposite side to the length of the hypotenuse. The disadvantage of this definition is that it is only applicable to angles that are between 0 and 90 degrees. How about for the angles that are less than 0? And how about the angles for greater than 90 degrees? The method in defining our trigonometric functions for those angles is via the coordinate system. In this method, the angle theta is described by a certain point. Here, we call that one x and y. Then, we measure the distance of this point to the origin. The trigonometric functions are essentially the relationship between the x, y coordinates and the distance r. For instance, the sine of theta is equal to the ratio of the y coordinate to the distance r. The advantage here is that we can apply this to any angle. Now, it's going to be much easier if we let r to be 1, and that will give us the unit circle. The unit circle is going to be useful in studying the behavior of our functions. To do that, let us consider the sine function. Some of the nice properties of the sine function are the following. First is, it is periodic with period 2 pi. This means that if we rotate this point here 2 pi around the circle, in other words 360 degrees, the point stays at the same place. Next is that we have these key angles. These are the quadrantal angles, 0, pi over 2, pi, which are basically the points around this circle here. Now, one more thing to note is that the values of our sine function can only be as large as 1 and as small as -1. Using these observations, we can plot the graph of our sine function. To start with, let us draw our Cartesian plane with the x-axis is plotted with pi and 2 pi. Then locate further the two angles, pi over 2 and 3 pi over 2. Next, we have to plot the points at which the sine function is 0. And these are precisely the angles 0, pi, and 2 pi. For the last part, we have to locate the maximum and minimum point of our sine function. In this case, the maximum occur at pi over 2 with maximum value of 1, and the minimum occur at 3 pi over 2 with minimum value of -1. Now, using these 5 points, we can carefully graph our sine function by tracing the point starting from the angle 0, passing through each point, and ending with 2 pi. And there we go. We have the graph of our sine function. We can also do the same thing with our cosine function. In this case, our period is still the same, 2 pi. The key angles are still the same, these quadrantal angles. Extremes are the same. Now, proceeding to the graph, we're going to start with the same Cartesian plane with a period that goes from 0 to 2 pi. Then we further plot pi over 2 and 3 pi over 2. However, this time, the values at which the cosine function is 0 are quite different. They're precisely the point at pi over 2 and 3 pi over 2. And lastly, similar to the sine function, we have to locate the maximum and the minimum points. For the cosine function, this occur at 0, a maximum, pi, a minimum, and another maximum at 2 pi. Now we trace the graph of our function starting from the maximum point at 0, passing through pi over 2, until we reach a 2 pi. And there we have it, the cosine function graph. And lastly, for the tangent function, we have a quite different properties. First off, we have the period is now pi instead of 2 pi. From this period, it turns out that what we need are these three quadrantal angles: negative pi over 2, 0, and pi over 2. And then the last ingredient in graphing the tangent function are the two asymptotes. One should note that the tangent function on the interval negative pi over 2 to pi over 2 is negative whenever the angle is negative and positive whenever the angle is positive. To plot the tangent function, we begin in plotting the x-axis starting from negative pi over 2 to pi over 2. Then, we locate the single zero that this tangent function has on this interval, which is precisely the origin. Then we proceed in plotting our asymptotes, which are x equals negative pi over 2 and x equals pi over 2. From that, we can trace the curve from the origin to the positive side and then from the origin to the negative side. And that's our tangent function.